Hello all, welcome to ML Industry, where we talk about all things machine learning. Today, we are going to discuss two fundamental components in machine learning: data and models. We will cover the following topics in this video: what is data, different types of data used in machine learning, what makes a data good data, what is population and sampling, what is model, and different types of models. So let's start with the first question. What is data? Data is the information or observations we collect and use to train a machine learning model. We can get data from different sources like sensors, databases, or user interactions. There are two types of data: labeled and unlabeled. Labeled data includes both input features and output labels. Unlabeled data includes only input features. For example, if we are building a house price prediction model, our data will consist of a dataset of houses with their sizes and prices. The data will have labeled input size and labeled output price. Now let's talk about different types of data inputs that a model can have. First, we have numeric data. It consists of continuous or discrete numeric values like temperature, age, height, salary, etc. For example, if we are building a model to predict a person's salary, we will use numeric data inputs like age, education level, and work experience. Secondly, we have categorical data, which consist of discrete values that represent categories or classes. Examples include gender, color, occupation, etc. For instance, if we are building a model that predicts the likelihood of a customer buying a product, we will use categorical data inputs like occupation, gender, income level, preferences, etc. Third, we have text data, which consist of strings of characters, such as sentences, paragraphs, or entire document. For instance, if we are building a model that analyzes customer feedback, we will use text data inputs. Next, we have image data, which consists of visual information in the form of pixels that represent an image. For example, if we are building a model that classifies images of animals as cats or dogs, we will use image data of cat and dog. And lastly, we have time series data, which consists of data points recorded over time. For example, stock price, weather data, or medical sensor data. If we are building a model, for instance, to predict stock price of a company, we will use time series data of that stock over a range of historical time. So I hope you have a holistic idea of what different data types can be used in a machine learning. But now the question is, how do we know if the data is good enough for the problem in hand? So let's see what makes a data good data. So first of all, good data needs to be clean. By clean, I mean free of errors, duplicates, and outliers. If our dataset is full of error or duplicates, it can skew our model performance and give us inaccurate results. Similarly, if we have outliers in our data, that is, values that are much higher or lower than the rest of the data, it can throw off our model and make it less reliable. Secondly, good data needs to be relevant. It's not just about having a large dataset, but it's about having a dataset that relevant to the problem we are trying to solve. For example, if we are trying to build a model to predict the price of houses, we need to have data on the features like size of the house, number of the bedrooms, number of the bathrooms, location, etc. But having a data like stock market price or weather will not help in this use case. Okay, so now let's see one more aspect of the data, that is population and sampling. In machine learning, population refers to the entire group of individuals or objects that a dataset represents. For example, if we are building a model to predict customer churn, the population would be the entire customer base of the company. Another example could be, if we are predicting human heights, the population would be the entire human population on Earth. But here's the thing, it's usually not practical or even possible to collect data from every single member of the population. Instead, we take sample of the population and use that to represent the entire group. So sampling is a critical process that represents the entire population. And there are many different sampling techniques we can use. For example, we might use simple random sampling, where we randomly select individuals from the population to be in our sample. Or we might use stratified sampling, where we divide the population into different groups we call strata, and then select individuals from each of the groups to be in our sample. There are other techniques also, like systematic sampling, cluster sampling, etc. And I will create a dedicated video to explain each of these sampling techniques in details. But the key thing to remember is the sample needs to be representative of the entire population. If our sample is biased in some way, then our predictions won't be accurate. For example, if we only select people whose height is less than 6 feet to train a height prediction model, then it won't be able to accurately predict the heights over 6 feet. So in this case, our data is biased. Now I hope you have got a better idea of what data and sampled data is. Now let's move on to the next big thing, that is model. So models are mathematical representations of the patterns and relationships that exist in the data. It's like a brain that has learned from the data and can be used to predict or decide on the new unseen inputs. Okay, we can create a model by training an algorithm on a dataset, and its purpose is to make predictions or decisions based on new data inputs. The training process involves feeding the algorithm a set of input data along with corresponding correct outputs and adjusting the model parameters until it accurately predicts the correct outputs for new unseen data. Okay, so there are many types of machine learning models, each with its own strengths and weaknesses. Let's have a look at few common type of models. So the first is linear regression. Linear regression is a simple model that models the relationship between a dependent variable and one or more independent variable as a linear equation. For example, a linear regression model could be used to predict a person's salary based on their age, education, work experience, etc. Okay. Now, the second model type is decision tree. A decision tree is tree-like structure that breaks down a complex decision-making process into a series of simple yes-no questions. Each question leads to a new branch of the tree until it finds a decision and delivers it to the asked question. For example, a decision tree model could be used to classify images of animals as cats or dogs based on their visual features. Next is neural network. Neural network model is inspired by the structure of human brain with interconnected layers of artificial neurons that process the input data and produce output predictions. Neural network can be used for a variety of tasks such as image classification, speech recognition, and natural language processing. Okay. Next type of model is support vector machine. Support vector machine is, or in short, it called SVM, that separates data into different classes using hyperplane in high dimensional space. SVM are often used for binary classification tasks such as predicting whether a customer will churn or not. Next model example is K nearest neighbor. K nearest neighbor or KNN model is a simple instance based model that classifies new data points based on their proximity to existing labeled data points. KNN is often used for classification tasks such as classifying images or identifying spam mails, etc. Don't worry if you have heard some foreign words or some concepts that is very new to you. I will explain each of the models and give you detailed information with a code base so that you understand each of the concepts fully. Right now I am giving you just few examples how different model can work like. Okay, and these are just few examples of machine learning models that are used in practice. So in conclusion, both data and model are crucial component, and the choice which model to use depend on specific problem and characteristic of the data. Okay, I hope this video helped you to understand the basics of data and models in machine learning. Thank you for watching, and don't forget to subscribe to ML Industry for more exciting videos. See you in the next video. Till then, happy learning.